We always have to ponder on one side the purpose that the material is made for, and we will be trying to fulfill this purpose with as little energy as needed. And if you use less energy, you will emit less carbon dioxide as well. So I'm standing in front of a pile of building material. Some is metallic, so that's an extraction of parts of the ground, and then by melting it has been extracted from the mineral material. I'm standing on a composite material which is consisting of concrete. And here we have to do with a natural material. Wood. Natural materials could also be natural stone or sand, or normally if you use natural materials you need less energy to process them in a way to make them suitable for the building process. I'm standing in front of our materials collection on a surface of natural stone, but this natural stone has been imported from China. So as I am in Germany, importing stone from China it takes energy to transport it all the way down here. And you can see that these are wooden windows. I think it's a tropical wood. This is because this window has been aging so well. Might be Meranti or some specimen like that. We have been talking about natural materials which are not processed but used in a way that they are found in nature. So that could be wood, for example, or natural stone. Behind me you see an artificial stone. It's brick. So you mix clay with sand and then you burn it. So the burning process takes a lot of energy, but it makes the material longer lasting. I'm standing on a natural stone. In this case, it could be from Italy or so as well. We have an international building market. Particular problem are composite materials. Here you can see reinforced concrete. Well, this is a general problem of composite materials, that the two materials or more materials that you mix have to age together. So if we bind materials with a binder, like for example cement, you can produce concrete. And as you can see in these examples here, there are natural stone elements like these pebbles here included in the concrete matrix. So you have natural stone on one side and artificial stones that you create by taking a binder, like for example in this case cement, and then certain particles, can be glass, can be natural stone, can even be metals, and make artificial stone with it. So I'm standing in front of a sample of terrazzo, and as you can see, the student has been working with different colors and different natural stone inserts, and thus been creating something very particular. Here is another example with segments of aluminum tube and flat pieces of aluminum. All this has been grinded together, polished together, and gives you another terrazzo surface. And here another student who has been trying out a very clear matrix for the concrete and inserting roof tiles in it, or segments of roof tiles. So roof tiles are made out of artificial stone, where you take clay, mix it, and then burn it in an oven. And afterwards this has been inserted as a recycling good in this piece of terrazzo and then polished together with the cement matrix behind it. Another composite material would be reinforced glass. So as you can see, the metal wire is sticking out on the edge. So if this starts to rust, the glass plate could be exploded from the inside. So this has to be avoided, and if you want to work with this metal, it's advisable to finish the angle of the glass one way or the other, for example with a silicone paint. You still have the choice of the natural stone, like in this material collection here we have samples from different quarries. You could polish them on one side or leave them matte. So that's the surface treatment. On the other side here, you can have these little rails in the sample, or once again polish it. And even in a particular quarry, you might have variations from one side of the quarry to the other. Birch clay products would be much more regular than the natural stone qualities on the other side. And you could reproduce almost exactly the same element as in the last production process before. As it's a ceramic material, you can influence the color of the burnt mass, and you can also treat the surface with a special layer of ceramic surface treatment. Ceramic materials are pretty good in compression. If you want tension, then you have to insert metallic bars like above here. And if you want it to be especially insulating, then you might work with an insulation on the inside. Natural stone is derived from magma getting to the surface. Then you have different processes, densification and hardening processes. Then you have erosion and weathering processes. And then you could over the time harden them to get sandstone, limestone or slate. So all these are derived in one way or the other from the eruption stones like granite or gabbro or others here. We have them over here, diorite. So once you have extracted the natural material, then you can treat the surface of the blocks. To do this, you use special instruments like these hammers. You can have special effects on the natural stone surface, like vertical rails or these hammering effects or polishes. Here we have been taking ceramic tile system for facades, and you can see that they are mounted on aluminum rails, and in a material experiment we have been exchanging the ceramic tiles against wood concrete mixes. For a window, for example, you will try to use wood as a natural material. But then when you have to guarantee airtightness, you might work with plastics. Here for this weathering strip you use aluminum. Although aluminum takes a lot of energy to produce, you use it only at this very solicited point where all the water hits the profile, and by using aluminum we can extend the lifespan of this window profile by 10 or 20 years. This is an insulation plate that contains natural material. You can recognize it here on this side. It's wood fibers, and the wood fibers are impregnated with cement. Why do we have these surfaces? As to be able to adhere stucco to the surface. Behind this is a very popular construction, at least in Germany. This is very popular now. It's a composite system to insulate facades, and the weathering layer is rather thin. It's a stucco with a reinforcement grid on the inside. out of glass fibers. And well, you can see the problem as well that you have with this type of construction. It is mounted on a concrete wall. So the concrete wall stays at 20 to 25 degrees over the year. And the exterior surface goes down to minus 20 in winter and up to plus 80 degrees Celsius in summer. So there's a big movement between the interior, which stays rather stable, and the exterior, very thin layer, that moves a lot. Two different insulation materials. One is foam glass and the other one is wood fiber product. So the wood fiber product takes rather little energy to produce it. Foam glass is very interesting because it is less sensible to temperature. It always depends on what you want to use the materials for, whether the energy is well invested or not. Although this is a petrol-based material, it might be helpful in construction as well. You can have a glass layer on the outside, a glass layer on the inside, and take this petrol-based plastic web to immobilize the air on the inside. The same that I told you for natural stone, that there are many different variations of natural stone. We saw how they were created, is valid for wood. And as you know, there are different types of trees. This is, for example, oak, or here we have birch. And you see, if I cut it, the image that is created using the oak is very different of the birch. Oak will be lasting much longer if you use it unprotected on the outside than the birch would be. So here again, I have to evaluate where I want to use a material. And if the extra money that I might invest in oak wood is well invested or not. On one side you have the wood as it appears in nature, and on the other side the wood has been cut down to smaller particles like strands or fibers or whatsoever, and then re-glued together to form wood-derived product. As you can see, there are many different materials, and you don't have good materials and bad materials, but you will always try to use the materials in a way that is most adapted to their characteristics. And if you can use a material that takes less energy to produce, that emits less carbon dioxide during production, that's always preferable.